Okay, let's take a look at problem 9.3a, giving us units of inch, pounds, and seconds, medium difficulty, 10 minutes. Design intent, insert the small hole fork base at the origin, inserting components, coincident concentric width angle. All right, so once again, we're going to rely on this small hole fork base to be in position, and then we're going to have to determine where these angles equal spacing both sides. So whenever you see equal spacing both sides, that's pretty much going to mean a width mate to apply that rather than trying to do the calculation. So we're going to open up an assembly, and then we will browse, and it takes me back to the components. I go to 9.3 and small hole fork base. All right, so just by accepting it, it goes into origin to origin. Okay, so again, you can kind of just verify those by highlighting the origin. If I swap between them, it's just going to be a natural process of inserting the component. All right, so then it jumps to, let's go with the center block. And the center block, yeah, looks like it's pretty much aligned like that with the chamfers. So let's go with a concentric first. And I do want it to be able to rotate because we need additional mates that will ultimately define the angles in the center of mass. All right, so going to the paper clip, going to advanced, we're looking for that width mate, and don't know what I selected there, so I'm going to clear that out. When I'm applying the mates, I'm not real thrilled to have the colors on, so we'll take a look at doing those. So two faces from one object, two faces from the other object, and then it's going to center them. I'm going to go ahead and get out of that so that this rotates like so. All right, so when we insert the next component, we're looking, well, not the small pin. So we did that. I think it's going to be, the next one's going to be the large pin. So I'm going to want to go select, control select, and concentric. And if we drag that out a little bit more, it may behave kind of weird, but we're going to hold down the control button again, since we already have the through hole selected. Control select, either whichever one's easier to see, the one through the center block or on the base. All right, so moving along, we're going to go with the small pin. All right, so small must be referring to diameter. All right, so in this one, if we go concentric, what do we have to work with? So let's see. I would want to center that. So let's see what we have in the way that this was generated. So since the front plane bisects the part, then I would be looking at the front plane. So since it stayed selected, I can just hold down the control button and go to the front plane of the block. All right, my other consideration was I was thinking about going to width and selecting that face and that face as one, and then that face and that face as the other. Since these have curvature to them, they're non-planar, that makes it a little more interesting to work with. So we get to the next. We're going to insert the components, and we're looking for the large fork, and we'll go ahead and put that into position. Just to kind of illustrate, we'll go ahead and use the rotation. Keep in mind that I think I mentioned previously that I've lost this block somewhere. So if we right click, you're going to have the same basic tools on that side. So actually, if we go one more on X, that puts it just a little bit closer. All right, so back to concentric. And I think we'll go right back to the width mate. So for the advanced mates, we'll go to the paperclip, click the advanced tab, we'll grab the width and pick that one again. So we'll go 1 and 2, and then 1 and 2. All right, so those should stay center. I can hit the right mouse button since it gave me the little check mark and I managed to see it. All right, so now we've got to determine what they're doing with these angles. So 31 degrees off of center. So I'm assuming that would be a top view, and section AA is looking, that's a weird, I guess you can't really, you probably could have pulled an auxiliary view. But since these are just kind of floating out in the space views, I'm still a little suspicious. So, and I have no idea what that one's doing. Oh, kind of looking at it as an auxiliary view through the end. Okay, so yeah, whatever that means. So let's go ahead into the to the top view, and we'll try to make some determinations here. All right, so I would like these two to be closer in the selection. So I can left click, hold down, and drag. It's not necessary, but visually it makes more sense to me. So there's a front plane. I don't think that's what I want. There's a right plane. All right, so the top plane, and then if we were to look at the front plane of the assembly, I think we can get the angle to 31 degrees from there. Okay, that gives me 1, and now we've got to figure out which two they're doing the 14 off of. All right, so it looks like, well, let's check the movement. So this is able now to rotate that way. So go back to the top. So yeah, that looks reasonable anyway. And then the 14 is going to be kind of a down angle. So I think I'm going to want to stay with the planes, and so make sure I don't get myself confused here. The right plane, the top plane. Let's see if we can generate that without. Oh, and yeah, no, that was strange. So let's reverse it. No, let's change the mate alignment. Okay, if I hit that button enough, we'll see if it gets pretty close. All right, so that was yeah, that was a little strange. Still want to say on that view though, did I lose one of them? Yeah, I grabbed the wrong window there. There we go. So let's see if we can zoom up on this. So from the top, it kind of goes down and that way. And I'm not sure what that view is other than the 14. So let's just check that real quick by going to the top. All right, well, we've got our center of mass, 4.63, 0.51, and 0.25. So either hit it or I missed it. So we have 4.63 minus 0.21 and 0.53. So I got something reversed. All right, but it looks good. So let's double check the numbers. So one of the advantages of putting the angles in last is that if I were to change these 14 and we go to the other one, and I'm not going to spend too much time messing with this. It is more about the process here. And let's change that one over to the 31 and see if I just happen to get those reversed. All right, minus 0.51. So I am a little closer. I got the 0.25. So this has some interpretation issues with it. I'm not feeling too bad. So the y of minus 0.51 now. So now I have to figure out which one actually needs to reverse. I'm pretty sure that wasn't going up. So let's flip the dimension. And just to do the experiment. All right. Okay, I did not get that from their pictures. So if I go to the top view and go to the bottom view, yeah, sort of seeing that on section AA. All right, we got numbers. So that is an interesting interesting process. All right, somewhere then I lost, or I think I lost my mass properties window because I'm still seeing the moments and it did not move away. So here in the bottom, let's look for those little icons, because if they disappear, it's not going to let you do anything until you close that window. All right, so let's take a look at what's going on with 9.3b. So start with the 9.3a. We got 43 and 34. So I think that hopefully we will be able to find something similar. So if I double click on that, I should be able to see. And the quickest way is going to be to reverse that. And we'll try 34. All right, so this isn't going to be a good strategy if we're doing this for the CSWA, of course, but to try and get our numbers, I think, so I must have reversed that just enough, 439.58, 0.58. Okay, make sure that that gets closed. And we'll go 34. And back in, oh, did I rebuild? I think everything's okay. So 4.4, 0.58, 0.57, close enough. I don't know that we're going to be able to do much better than that. All right, so as long as you get something similar and you're seeing how the angles work, what the best selections are, and a lot of this is just going to come back to you need to do it enough to see, so that's going to update, and I'm going to call this one I've been doing, I think, the underscore. That if you do this enough, you'll start to, I think I've said before, coincident and concentric are your primary. Being able to understand that the advanced mates, those are pretty handy. The with mate, definitely. And then one of the things that we would like to be able to do, and let's see if most of the time this misalignment, if we're thinking socket head wobbly or drive shaft, something along those lines, most of the time we'd want to be able to see this turn. So to make this dynamic, it gets a little more interesting. So let's see what we can do with that. So I want to start and float the first, and most of this should be in place. So right is going to be coincident. Well, moved a little bit. So yeah, that wherever that was located, I didn't expect to see that move. Okay, so we'll just call this optional. Being able to get this thing to go dynamic. So I would like to see the temporary axes, and then we're going to make the top plane. Didn't give it to me, so we'll go ahead into the paperclip. Oh, it kicked out my temporary axis, so coincident. And then we'll go to the front plane. I think that was the next one. Okay, so that should allow that to turn, which was what I was aiming for. So now that we have something that is dynamic, I think, which one am I going to be looking for? Oh, I added the coincidences. Let's go back and do, I should be able to do a 0 degree. And then we're just looking at this. Oh, interesting. So it moved when that had an angle in it. So I can't say I know what I told it to do there. Well, it has some movement that still solves. So actually, let's go ahead and suppress one of those, and I'm going to try the hit and miss method of getting this to rotate. So, all right, so we can see the movement. This is also something where we would want to analyze potential collisions. So in the move component, we'll review this again, the collision detection. Let's just go from here to here. And when I select it and it moves, it's gonna hopefully, maybe I didn't tell it to stop or I kicked it out too soon. Collision detection, this time I'll pay attention to what I'm doing. Resume drag, all right, so missed something, it's already colliding. So it's probably not going to, well, no, let me move that away. But I kind of expected it to highlight again when it got to another level of collision. All right, so useful tools. We have some other things that we can work with. If I were to probably, since I use the planes, if I were to do something similar with the temporary axis, again, I don't want to turn everything off. Make sure that that stays with the lighter background, because as soon as it goes gray, everything's grayed out except for the decals. All right, so if I go back to the temporary axes and I were to change the mate from the planes to set the angle, then I think that would probably work a little bit better. But just want to give you an idea of some of the options that we can build into this. So again, messing with this part is going to be optional, and there's other ways that we can set the dynamic motion.